We're on topic 10, and what we're going to do here is apply the rules that we've learned about exponents to examples. So page 49 has 4 examples, 1, 2, 3, and 4 here. And what we'll do is we'll go over each one of these individually and apply what we learned about exponents and the rules regarding exponents. So the first one that we're asked to do, and first of all, whenever we're doing these problems, we're usually asked to indicate the answer with positive exponents only. So let's take this very simple problem here, and we're going to handle the numerator and the denominator separately. So first of all, we're going to multiply a squared times a cubed under the product rule, and we add the exponents, 2 plus 3, and we get a to the 5th. Then using the power rule right here on the denominator, we multiply the 2 times the 3, and we get a to the 6th. So here again is the product rule. When we have a to the power m and a to the power n, we add the powers a plus n. The power rule, and usually you'll see this bracket here with the power right here, and you've got a power on the a here, so you multiply these two together. So it is the product. Okay. Now, once you've got a to the 5th and on the numerator and a to the 6th on the denominator, you simplify it further, and you bring a to the 6th from the denominator up to the numerator and subtract it. So there's a plus 6 here on the denominator. When you bring it up to the numerator, it becomes minus 6. And this is the quotient rule right here. And so 5 minus 6 gives us a to the minus 1. And again, we leave the answer with positive exponents. So this is, by definition, 1 over a to the power 1. And the 1 here, we just drop it. It's implied. When we write 1 over a, we mean 1 over a to the 1. So just something that might be useful when you are using and to distinguish between the product rule. We use some numbers here. We use for a, we put in the power letter a, we put in the power, we put in the number 2, and we multiply 2 cubed by 2 squared. Using the product rule, we add 3 and 2, and we get 5. And 2 to the 5th is 32. If you multiply 2 by itself 5 times, you get 32. Now, using the power rule, here you see this bracket, and the 2 here, you're going to multiply the 3 times 2 is 2 to the 6, which is 64. So, assuming that you know this, okay, you probably good to memorize that 2 to the 6 is 64. Just multiply 2 by itself 6 times and get 64. Multiply 2 by itself, you get 32. In fact, all you have to do is really know that 2 to the 5th is 32. And then if you multiply 32 by 2, you get 64. And the 2 to the 5th changes to 2 to the 6th. Now, supposing you wrote incorrectly, and you were just checking, you wanted to see whether this was true, and you wrote incorrectly that 2 cubed times 2 squared is 2 to the 6. That's wrong. But let's take, how would you tell that it was wrong? Well, the 2 cubed is 8. 2 multiplied by itself 3 times is 8. 2 multiplied by itself is 4, 2 squared, and 8 times 4 is 32. Well, the left side would be 32, but you know that 2 to the 6th is 64, so 32 can't equal 64, so you've got the wrong number right here. This should be 5. Anyway, same thing over here. Supposing you want to check this rule and you made a mistake. You could see that you could make a mistake if you did the following analysis. Here, this should be 2 to the 6, but you added these two instead of multiplying them. So the left side, 2 cubed is 8. 8 squared is 64. And 2 to the 5th is 32. So you can see that you've got the wrong rule. Anyway, that might help just to remember that, you know, how to apply these rules. But of course, they are, what the rules that we're talking about is this one and this one here. After a while, you don't really recognize what rules you're using. You just go ahead and use them. You may not remember the names. Now, number 2, simplify expressing the answers with positive exponents only. So right over here we have 2a squared divided by 3b cubed, all in brackets, squared. So what we're going to do is handle the numerator separately from the denominator. Now we're going to divide this so that the squared applies to the numerator and the squared applies to the denominator. And the rule here is a to the n, a over b to the nth power. A over b to the nth power is a to the n, b to the n. It was under property 2 that we discussed. So what we're going to apply is the 2 to the numerator, which gives us 2a squared squared. So you're just taking the whole numerator right here, this part of it, and squaring it. Then we take the whole denominator part, 3b cubed, and square it because of this number 2 here. Okay? And then what we're going to do is apply the squared to each component in here. So we're going to take 2 and we'll square it. Remember, when I write 2, we mean 2 to the 1. 2 means 2 to the 1. So when I multiply the 1 times the 2, okay, I get 2. Then I'm going to take a squared squared. Then I'm going to take 3, which is 1, 3 to the power 1, multiply it by the 2, and get 3 squared. And then I'm going to take the b cubed and I'm going to square it. So I'm applying the squared property, in this case, to each individual part. And what we're doing in doing that is we're using property 1, ab to the nth power. Remember, there's a 1 above the a, power 1 above the b, so we get a 1 times n, which is a to the n, and b 1 times n, which is b to the n. So now that we've got this, we're simply going to use the power rule on this part of the problem here and this part of the problem here. We know that 2 squared is 4. We know that 3 squared is 9. I multiply the 2 times the 2 right here, and I get 4. I multiply the 3 times the 2, and I get the 6 right here. So everything is now with positive exponents only. Now, in example 3, we're given 3x squared to the minus 2, 2y cubed to the minus 3. And what we're going to use is use property 3, where we have a to the minus m. Move that down to the denominator, from the numerator to the denominator, and make it positive. And move this from the denominator to the numerator and make the power positive. So what's happened here is we're taking 3x squared minus to the power minus 2, moving it to the denominator, becomes plus 2, taking the 2y cubed to the minus 3, and bringing it up to the numerator. And we've used this property here. Now we're going to apply the cube to each individual. So there's a 1 implied here. 1 times 3 is 3. We take y cubed, multiply it by 3. Okay, we're going to cube it, sorry, we're going to just apply the power cubed to the y cubed. We're going to apply the 2, power 2 to the 3, and we get 3 squared. And we're going to square the x squared, and we get this. Now, we know that the 2 cubed is 8. The 3 squared is 9. Now we're going to use the power rule, multiply 3 times 3. We get 9. 2 times 2, and we get 4. So really all that's new here is this part right here where we've used this rule, this property 3 rule here. Again, same kind of situation where we have x minus 2 to the minus 4, right? And over 2y cubed on the denominator, obviously to the minus 4. And what we're going to do is we're going to bring this x to the minus 2 down to the bottom here, x to the minus 2, and the 2y cubed, and bring that up there. And what we're doing is changing the minus 4 to the plus 4. So all we're doing is taking a over b to the minus n, putting the b over here, putting the a down here, and changing the power. So that's all we're doing. We're moving this to here, we're moving that to there, and we're changing the power. And that's property 4. So once we've got this, we're going to take each individual component. We're going to actually break this into the numerator part and the denominator part. So we're going to apply the 4th power to the 2y cubed right here, and we're going to apply the 4th power to the x to the minus 2 right here. So now we have 2 to the 4th, which is 16 right here. We're going to multiply 3 times 4, we get 12. And this is going to give us minus 2 times 4 is going to give us minus 8. Now I think it's better we just go directly here, move the x to the minus 8 from the denominator up to the numerator. This is on the denominator, this is on the numerator. Just forget about this step. We'll go over it a little later on. Okay, but the best way, the easiest way is just move the x to the minus 8 to the numerator. That's all that's happened by the definition. Okay, so these are the 4 examples, and the best thing to do is just to try these on your own without looking at the procedure and see if you can come out with the answer.